4.5, we're going to start to take a look at solving polynomial equations. Now, before we get to there, I just want to talk a little bit about graphs and something about multiplicity and repeated zeros. And so here's a definition. When x minus k is raised to an odd power, the graph crosses the x-axis at x equals k, or at that zero. So an example of something raised to an odd power is x plus 2 to the third power, or just x. X is raised to the first power, which is an odd power, right? Number 1. X minus 3 is also raised to an odd power, that's just to the power of 1, so it's odd. So what we're saying is at that point, so at x equals 3, for example, then it would pass through that x-axis. It crosses the x-axis. Now, when x minus k is raised to an even power, the graph will touch or bounce at the x-axis at x equals k. So some examples of those are like x squared. So think about a parabola. It bounces off of the x-axis. Or x minus 5 to the square, for example. So if I were to draw that out, it bounces, kind of like a U shape. So I like saying bounces because then it's like bouncing on the ground, right? So it does touch it, but I like saying that it bounces at that point. So what we're going to do is we're going to solve a polynomial equation. So we're finding the x-intercepts, and then we're also going to graph. So here's an example. Solve 2x cubed minus 12x squared plus 18x equals 0. So what we want to do is we're going to factor. So always take a look at GCF first. What can I divide out of all the terms? And so I can divide out a 2 and an x, right? They all have factors of 2 and x. Again, you can look at that last term, and that can clue you on the variable of what you can divide, right? The highest one. And each one has at least an x, so that's what I can divide. So we're actually dividing 2x to the 0 as well. But 0 over 2x is 0. Now, when we divide out that 2x, it goes to the front. So remember that. Then what we're left with is x squared minus 6x plus 9, and that equals 0. Then we factor. So what multiplies to 9 that adds to negative 6? And that's negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. Negative 3 plus 3 is a negative 6. So times and plus. So here are our factors. So we can write x minus 3 times x minus 3 equals 0. So notice it happens twice. So I'm going to rewrite this. 2x times x minus 3 to the square equals 0. So let's use zero product property. Zero product property, you just set each piece equal to 0 and solve for x. It's what makes it 0. So we divide by 2. So we know that x is 0. That's one of our x-intercepts. And our other x-intercept, we add 3 to both sides. We find that x is a positive 3, but I notice that there is a square here. The square tells me that it's going to bounce or touch the x-axis. So that was our definition in the beginning. So one way that I'm just going to notate that for us, just so we remember, is that it's B for bounce. I don't want to say repeated because we could have different repeats. We could have it raised to the third power. And if it's raised to the third power, then that actually passes, right? So just thinking about those terms. So if I just write B that tells me it's even, I know it's going to bounce at that positive 3. Now another thing we're going to look at is the degree of the polynomial and the sign of the leading coefficient. So this is from a previous lesson. So the degree of the polynomial, the highest degree, the highest exponent is 3, which means it's odd, right? The degree is odd. Then the leading coefficient sign is positive, right? We're just focusing on the 2x to the third power here. So that tells me about my end behavior of the graph. So odd, positive, that means the ends are going in opposite directions. So I'm just going to sketch the right side. It's going to go up on the right and down on the left. So those help me with at least where I'm drawing it. Where am I going to start and where am I going to end? Okay. And then the 3 tells the x-intercepts tell me where it's going to touch, cross, at the x-axis. Now those are the only places that it'll ever touch the x-axis are zeros. So the 3, remember I said it was going to bounce, so I'm just going to write B here just to kind of help me remind myself that it's going to bounce there. And so let me start at the 4. at the 4. I'm going to start at the upper right corner. I don't know why I said 4. And then it's going to come down, right? I've got to touch the x-axis here, and it's going to bounce. So meaning that it's not going to cross. It's bouncing off of it like a parabola bounces off of the x-axis if it's just shifted to the right. And then it's going to come up somewhere and then pass through the 0, right? It was raised to the first power here, so it passes through. And so this is our graph. And then it's good to label our end behavior. So let's just focus on the y's first of all. So on the left side, we know that y is approaching negative infinity, and on the right, y is approaching positive infinity. So let's take a look at letter A. Try one more example. We have negative 2x to the 4th plus 16x squared minus 32. We want to solve the equation. We're solving for the x-intercepts. So for the f of x, we're just going to set it equal to 0. Then we're going to use GCF. What can I divide out of everything? So I know I can divide out a 2. So let's go ahead and divide out a negative 2. And then there's no x that I can divide out, so that's the most that I can do. So 0, negative 2. I'm left with x to the 4th minus 8x squared plus 16. So now I need to factor x to the 4th and 16. So it multiplies to 16 that adds to negative 8, and that is going to be negative 4 and negative 4. So we get 0 equals negative 2. Now x to the 4th, so remember that's just, we could cut it in half. So x to the 4th, just cut that in half. And so we'll plug that in half as x squared and x squared. Now, why did I do that? So x squared times x squared is x to the 4th. And then if I add the polynomials, whatever is left over, I'm going to get x squared. Okay, so just kind of short review of what we've done previously. So x squared and x squared, you just cut it in half because remember x squared times x squared is x to the 4th. Then we have negative 4 and negative 4. And so I'm going to leave it like this. Like I'm not going to combine it because I notice that x squared minus 4, that's a difference of 2 squares. Dots, difference of 2 squares. So again, that's when you have a negative sign in the center, and I could square root the front and square root the back, right? That's a perfect square. And so square rooting the front and back, so we'll do the front one first, square root. So we have 0 equals negative 2. Square root of x squared is x. Square root of 4 is 2, and then it's plus or minus, so difference of 2 squares. Let's do the back now, and it's the same exact thing. And so what I'll get is x minus 2, x plus 2. And so now notice we have 4 x's here. We have some repeats here, and that's okay. And so now I'm going to condense it. Now that it's completely factored out, I notice that I have x plus 2. I have 2x plus 2's. And then I have 2x minus 2's. And they're both squared. So what that tells me is that it's going to bounce at those x-intercepts. So x equals negative 2, and it's going to bounce because it's squared. X equals a positive 2, and it's going to bounce because it's squared. So those are some important pieces. Negative 2, and it's going to bounce. And a positive 2, and it's going to bounce, meaning it's not going to pass through. Now let's look at our y-intercept. Looking at the original function, and our constant is negative 32. So it's 0, negative 32. So their y-intercept here. Now let's look at end behavior. What is the degree and leading coefficient? Degree is the highest exponent of the polynomial, which is 4. That means it's even. And so when you focus on the term with the highest exponent, we look at that coefficient, which is our leading coefficient. That sign is negative. So even negative means the ends are both going down and down. So again, those help us with our beginning. We're going to start at one of the arrows and end at one of the arrows, making sure we're passing through or bouncing at the spots that we say. So I'm going to start at the left arrow. It's going to bounce at the negative 2, come back down. It has to pass through that negative 32. And then it's going to bounce off of that positive 2 and continue on to negative infinity. And so here is our graph.